I'd like to tell you about a product that I created at the University of Illinois Springfield to solve the epidemic of nutrient pollution in the world's water. Contaminated water is such a big issue that 190 countries have pledged by the year 2030 to reduce untreated wastewater, to cut nitrogen waste in half, and to clean up a third of the world's coasts. We're currently making very little progress towards achieving this goal, and if we don't change something soon, we're going to keep seeing headlines like these: vacated beaches and lost tourism, dead dolphins, a devastated fishing industry, and toxic algae, potential fines in Germany, blue baby syndrome in Gaza, and cancer in the United States. This is a complicated issue. Take a step back for a second. I spent some time earlier this week in Bavaria and got to see some fields, agricultural fields. Reminded me of my home state of Illinois. We rely on these agricultural processes, and our urban ones too, to support the modern society in which we live. But they produce runoff that carries nutrients throughout the water channels of our world. These water channels are our backyards, our lakes, our streams, and our rivers. And we have to take an aggressive step. Enter EnviroCat, an environmentally friendly catalyst. It's a biochar support covered in nanoparticles that works with the naturally denitrifying bacteria in our water to remove up to 80% of nitrate in 100 hours. This exceeds the USA's Environmental Protection Agency's mandate of 15% to the Midwest, and that of the international community's 50% goal. I've made EnviroCat using sustainable materials. It's cost-effective and it's scalable. It's functional with the technology that we use to promote agriculture, and we can use it with current nutrient loss reduction strategies. The current strategies we have do not meet the goals. Most of them don't even get to 10%. So if we can take something that's 80% effective and introduce it to all of the waterways of the world, implement it in the form of a filter, we can reuse it and reclaim it and put it back out into our streams. We can put it in all of the high-risk areas of the world. We can work in many different countries, and it's sustainable, scalable, cost-effective enough that you yourself could buy some for your own property without feeling guilty about introducing any new contaminants to the waste or to the water streams. There are some implications for wastewater treatment, although we haven't looked at them yet. But I would like to put this in Filter the Waterways of the World, because when it comes to the water quality of the world, we want to reach that 2030 water goal. But when it comes to your water quality, which is my water quality, our water quality, I don't want to wait. I want the wall to fall now.